Well, welcome back to Class 7 in this 12-part series in learning the Dart programming language. In this section, we'll learn all about Dart libraries, importing libraries and modules. Then we'll shift into Cascade Notation. Let's get started. A library in a coding language is a collection of files and packages used for a general purpose. For example, audio file programming in the browser. A Dart program consists of one or more libraries, and it may be built out of one or more compilation units. A compilation unit may be a library or a part of a library. Dart has a set of internal libraries that come with the Dart install that provide essential functionality for your programming needs. For example, there's the core library that contains Dart's built-in types. We've already covered that in a previous session. Then there's also the math library that contains, as you would imagine, math functions. The import and library directives can help you create a modular and shareable code base. Libraries are a unit of privacy. Identifiers that start with an underscore, some call it an underbar, are visible only inside the library. Every Dart app is a library, even if it doesn't use a library directive. Libraries can be distributed using publicly available packages by going to pub.dev. Use the import keyword to specify how a namespace from one library is used in the scope of another library. If you wish to make use of a library's functionality in the code module or file that you are creating, you use the import keyword. Here is an example. Import, and in quotes, Dart:/HTML. For internal Dart libraries, we use the special Dart:/library name scheme. Down here, for other libraries, you can use a file system path or package scheme if you're using a package manager like the pub tool from Dart. So it would be import, and then in quotes, package, /device_info.dart. So the path right to the file. Okay, so here we have an example of using a built-in library. So we use the import, and then in quotes, Dart:/math. So I'm going to use the random class from the built-in Dart math library. I first create an instance of random, and I store it in a variable I'm calling random, lowercase. Then I use the nextInt method up to the number 10. So what happens here is every time I run the code, I'll get a number between 0 and 9. Dart uses zero-based indexing, as we've mentioned before, so numbers up through 10 would be numbers 0 through 9. Now here's an example where we have called to use a function defined in one file from inside another. Caller.dart is the file that I'm going to use to call the function that is defined somewhere else. Imports.dart is where that function that I'm calling in is defined. So the objective is to use the function myfunc defined in imports.dart module from within the caller.dart file. We have to do two things to make this happen. We have to import the file where the function we want to use is defined, and then we have to call the function from our calling module, just like we would any other function, no matter where it's defined. So here we have in caller.dart import imports.dart. So very simply stated, this imports.dart lives at the same directory location as caller.dart. So this becomes the full path. Then in my main function, I am printing myfunc, which is the function defined inside of imports.dart. So it's that easy to be able to define code somewhere. Maybe it all has to do with one thing, and then use it from other modules that you are creating. This really expands all sorts of possibilities. Now we switch gears a little bit here. We move away from imports and libraries, and we go into this thing called Cascade Notation. This may seem very foreign to you if you see it for the first time in Dart, like it was for me. Cascades allow you to make a sequence of operations on the same object. In addition to function calls, you can also access fields on the same object. So when you see this dot dot and then a function, this is a telltale sign that you're dealing with a cascade. So look at what I have here. First of all, I have a class defined, so forgive me, it was just easiest to show you in this manner. I have an instance of a class, just like a few slides ago I was using an instance of the random class. So this is the same type of thing. I defined a class called math. My instance is called M1. Now I have M1, and on the next line, dot dot add, dot dot sub, dot dot mult, dot dot div. So I'm adding, I'm subtracting, I'm multiplying, I'm dividing two different numbers. These are all defined in the class. It doesn't matter. What matters is that this is allowing me to operate on this one object, this one instance of a class M1, and perform all these different functions on them. It would be the same as this here on the right hand side. M1.add, put in my arguments. M1.sub, put in my arguments, M1.mult, and so on. So you see what a savings this is for me to be able to use it this way. And even if you never use it, it's important that you're able to identify it and understand what it's doing should you come into contact with it, especially as we start to use Flutter. My fine friends, thank you for making it all the way to the end. I hope you found this valuable. If you did, do a couple of things. Subscribe to the page, give me a like, leave a comment, and share this with somebody who might need it. We're trying to start a revolution here.